Earth's atmosphere isn't the only layer of protection our planet has from harmful solar radiation. Our planet's magnetic poles also do a lot to shield us from the dangers of space. But lately, scientists have discovered that the magnetic poles have been acting strangely in the last few decades. From changing their position to picking speed as they move, will the poles change positions? And what will happen when they do? Well, join us in today's video. Our planet has two sets of poles: magnetic poles and geographic poles. For most people, the geographic poles, which are the North and South Pole, where the lines of longitude converge, are the most popular. Ideally, the geographic North Pole is located at the center of the Arctic Ocean, while the geographic South Pole is found down in Antarctica. Magnetic poles are also located on the north and southernmost region of our planet, but are precisely situated where the magnetic lines of attraction enter Earth. The current location of the magnetic North Pole is found on Ellesmere Island in northern Canada. When using a magnetic compass, the needle which points to true north actually aligns itself with the magnetic North Pole and not the geographic North Pole. This is significant because both poles may be located in the northern Arctic region, but they are actually about 310 miles apart, according to geography. Earth's magnetic poles do not have fixed positions like the geographic poles and tend to shift over time with respect to changes in the Earth's core. The magnetic North Pole was first identified by British polar explorer James Clark Ross back in 1831, where he placed its location to be on the Bothes Peninsula in Canada's Nunavut territory. But since its discovery, the magnetic North Pole has shifted its position ever so slowly but gradually over the last century. This movement caused no need for alarm, as this change was slow and steady until the last few decades, when it picked up speed, moving as much as 35 miles per year in the northwest direction. Before we get into what is causing the poles to move at such speeds, first we need to understand what causes the Earth's magnetic field in the first place. What causes the Earth's magnetic field? Earth's unique magnetic field is made up of invisible forces of attraction and repulsion that are generated by what is known as the geodynamo process. Our planet is able to generate this magnetic field because it rotates at high speeds and has a fluid interior iron core, generating lines of current that surround the planet. Imagine a layer of sloshing iron liquid located in Earth's outer core, which is about 2,000 miles beneath the surface. As our planet spins, this incredibly hot iron liquid generates a magnetic field that pushes out around our planet, protecting us against harsh solar winds, and also acts as a guide for all navigation systems on the planet. Other planets in the solar system also possess their own unique magnetic fields, with planets like Uranus, Jupiter, Neptune, and Saturn all having magnetic fields much more powerful than Earth's. Planets like Mars unfortunately no longer have a magnetic field, which led to solar winds stripping away its carbon-filled atmosphere alongside any water the red planet may have had some 3.7 billion years ago. Venus also lacks a magnetic field, as it doesn't spin fast enough to generate one. Fortunately for us, Earth has maintained its magnetic field for billions of years, creating what is known as the magnetosphere. The magnetosphere is the region where solar winds are repelled, which would have otherwise eroded our oxygen-rich atmosphere, evaporated our oceans, and left Earth just as lifeless and barren as Mars. But Earth's magnetic field isn't completely invincible and can take a hit from strong space events like coronal mass ejections or CMEs from the Sun. These powerful CMEs can penetrate the magnetosphere and cause geomagnetic storms that cause widespread power and radio blackouts around the world. They can also affect astronauts in space as well as satellites in orbit, which would lead to unstable communication systems on Earth. One such powerful CME was recorded in 1859, when a solar storm, referred to as the Carrington event, caused global telegraph failures. Another such event also happened in 1981, when a solar flare from a CME caused widespread electrical blackouts in Quebec, Canada, for over 12 hours. Although these disturbances can be destructive, there are some less harmful and, dare say, beautiful side effects of magnetic disturbances. These are in the form of the northern lights, or the auroras in the planet's polar regions, which happen when disturbances in the magnetic field cause a reaction of atoms in the atmosphere, leading to the beautiful aurora lights we see. While these are all normal occurrences, scientists have noticed that the movement of the poles has been strange in the last few decades. Since Earth's magnetic field is generated by the movement of molten iron in the planet's outer core, the flow of this iron liquid can influence the location and position of the planet's magnetic poles. Throughout Earth's history, the poles have drifted and even completely swapped places thousands of times in the last few billion years. But scientists are not concerned as to why the poles are shifting, but how quickly the change is happening. In the last century, the poles were observed to move at an average of 5 miles per year, but between 1995 and 2005, Earth's magnetic North Pole has shifted at an average distance of up to 37 miles in a single year. Using data from the European Space Administration's swarm satellites, scientists have discovered that the speed with which the North Pole is shifting is largely determined by some anomalies detected under the tectonic plates between Canada and Siberia. According to the data, between 1970 and 1999, the systemic flow of molten iron underneath the Earth's outer core has drastically changed. Due to these changes, the electromagnetic pull from this region has shifted, which is now stronger beneath the Siberian side of a tectonic plate, causing it to pull the northern magnetic pole faster towards Siberia. By 2017, the magnetic North Pole had shifted about 240 miles away from the geographic North Pole. This recent movement has been so rapid that global geological surveys and environmental information centers have had to update the world magnetic model much faster than usual to keep up with the current location of the magnetic North Pole. As of 2021, the pole has moved beyond the Canadian Arctic and now moves at an average of over 28 miles per year since the year 2020. Scientists have tried to predict the movement of the magnetic North Pole and have stated that although they believe the pole will continue to move towards Siberia, it is difficult to predict with pinpoint accuracy how fast and in what direction the pole will move. One major question people have asked is, what are the consequences of a pole shift, and how would it affect life on Earth? Scientists have stated that however drastic the current pole shift may appear to be, these shifts are not new and have actually happened a lot throughout Earth's history. In the last 200 million years, the magnetic poles have reversed and swapped places hundreds of times, such that north becomes south and south becomes north. According to scientific estimates from NASA, the magnetic poles tend to flip approximately once every 200,000 to 300,000 years, but noted that it has indeed been more than twice as long since the last pole shift. The last magnetic pole shift was traced back to approximately 790,000 years ago, and scientists believe we are long overdue for another pole shift. However, scientists have reassured that the magnetic poles do not switch overnight, and it will take hundreds, even thousands of years for the poles to completely flip and switch places. So what would happen if the poles flipped? While some theorists have suggested that a natural geological occurrence such as the pole shift may cause destruction, scientists have revealed that evidence from geologic and fossil records has indicated that there have been no drastic effects of pole shift on Earth. Studies carried out on sediment cores and fossil rocks taken from deep within the ocean floors show a link between magnetic field activity and their corresponding effects on Earth. Scientists have been able to study sedimentary fossils from 790,000 years ago, which was the last time the poles reversed, and have found that there were no drastic impacts on plant and animal life at the time. Deep ocean sediments from around that period have also indicated that there were no drastic changes in glacial activity based on the amount of oxygen isotopes contained in the sediment cores. In essence, while the magnetic poles may be shifting faster than have ever been recorded in human history, it is safe to say that other than changes in the direction of magnetic north on navigation systems, there will be no drastic effects on environmental factors on the planet. So this is one doomsday event we don't have to worry about.